Chapter 6 Review Part 1. You're going to find out the log 5 1 equals 0. So to find that, you're going to turn that into an exponential form. So that is going to be 5 to the 0 equals 1, and that is your exponential form. You're writing number 2 into logarithmic form. So base stays the same. You're going to write this as log 10 of 100 equals negative 2. Number 3, you're going to write this in exponential form. So you're going to write it as 5 to the power x equals 125. And 125 you can write as 1 over 5 to the power 2, which is ultimately 5 to the power negative 2. So 5 to the power negative 2. Base same, powers equal, so x equals negative 2. For letter B, 6 to the power x equals 216. So you're going to have to figure out what is x that gives you 216 is x should be 3. So x equals 3. For letter C, 16 to the power x equals 4. If you want to write it into same basis, you can write 16 as 4 to the power 2. X is already there, and that is going to be 2x equals 1, or x equals 1 over 2. Another way of thinking is that whenever you have a number going from bigger to smaller, it means that x should be a fraction, or it should be a 16 to the power 1 over 2, or square root of 16 is 4. So in both cases, x should be equals 1 over 2. So answer is x equals, so this one is x equals 1 over 2. For number 4, you're going to apply the power property, which will kick the power outside. 11 times ln e, 7 times ln e. Ln e is always 1, so this is 1, this is 1. So you're going to have 11 minus 7, and that's going to be 4. For letter B, log base 3, you can write 9 as 3 to the power 2. 4x is already there. So you got here is log 3 to the power 8x. And the answer for this one, even if you kick the power outside, log 3 of 3 is always 1. So answer is just 8x. So question number 5, given the following, use properties of logarithm to evaluate. Now log A4 is given as 3.2, log 5 is given as 4.6, and log 12 is given as 6.2. We're going to use these values and evaluate the following letter A, B, and C. We will always try to break this 20 in a form so that we can use this and this, or out of any number that are on the top. So I'm going to break this 20 as 4 times 5 and apply the product property, which is 4 log of 4 plus log of 5, and that is 3.2 plus 4.6. So ultimately the answer should be 7.8. If you notice that the 3 is not in these numbers, so how can we use these numbers if the 3 is not even there? If it's not there, at least we can make 3 out of these numbers. So what I'm trying to say here, we are going to take this 3 and write it in the form of 12 over 4. Since we have 12 and 4, so we break this 3 as 12 over 4. And now we are going to apply the property of quotient. So which is going to be 12, log of 12 minus log of 4. And that's 6.8 minus 3.2. So 8 minus 2 is 6, and this is 3.6. For letter 6, we are going to break the 16 as 4 times 4. And you're going to apply the formula of product property. And that is 3.2 plus 3.2, which is 6.4. For number 6, you're going to make this log into expanded form. So first step is to apply the quotient property. Log of y to the power 3 minus log 7x. Kick the power outside by power property. And here you're going to apply the product property, which is log 7 plus log x. But when you distribute the negative, it's going to be negative log x. Number 7, you're applying the properties of power property. First, plus log 12, and here power property again. So what do you got here is log 4 plus log 12 minus 8 to the power 1 over 3 means you're taking cube root of 8, which is going to be 2. You're going to apply the product property here. So log 12 times 4. So log 12 times 4, 48. And here you're going to apply the quotient property. So log 48 divided by 2. And you're going to get here is log 24. For question number 8, we're going to find out the parent graph and if it's a growth or decay. We are looking at the parent graph, that is this purple graph. Any graph that has a 0, 1 is your cutting point at y-axis is going to be your parent graph. And it's rising from left to right, so this is going to be a growth graph. Parent function is always going to be 1, b. Now we have to figure out what is the y value or b value. So you can see that this point is 1, 3. It means that my parent function is 3 to the power x. To find out the blue graph transformation, you see from here how many unit left or right and how many unit down. So from here, if you go 1, 2, 3 unit left, 1, 2, 3, 4 unit down. So 3 left, 4 down, and that is your transformation. And gx, which is your graph, 3 to the power x plus 3 minus 4. X plus 3 minus 4 is going to be your equation of the graph of gx. So for question number 9, if in order to graph the log 2x minus 3 plus 5, first you want to know what is the parent function of log 2. So the parent function of log 2 is log 2x. You change that into exponential function, which is 2 to the power x. And that is what you're going to graph. You choose any points, any 3 points. So normally is -1, 0, and 1. 2 to the power -1 is 1 over 2. 2 to the power 0 is 1. And 2 to the power 1 is 2. Now you're going to change this into the form that is a log form, and that is log 2x is a parent function of log 2 of x without the translation. Now here you're going to switch the points. So this goes here. Switch x and y. And this one goes here, which is 1 over 2, 1 and 2. The parent function for log is log of 2x. So we're going to graph the parent function, and then we are going to translate this 3 to the right and 5 up. So our parent function is log 2x. Our transformation is 3 right, 5 up. And the graph is going to look like for log is half comma -1 is this point, 1 comma 0. So this is the point 1 comma 0 here, 2 comma 1. So 2 comma 1, that is this point, and that is going to be your logarithmic function log 2x. Now we are going to graph this, the translated graph, where you're going to move each point 3 unit right and 5 unit up. So let's see from the center, 1, 2, 3 unit right, and 1, 2, 3, 4, 5 unit up. This is my center point. This is my asymptote, that is this line is moved here 3 units to the right. So this is moved 3 right. And now I follow my next 2 points, which is this one and this one. So this is going to be my translated logarithm function, that is this function log 2x minus 3 plus 5. For number 10, you're going to find out the x value. If the bases are same, you're going to equal the power and solve for x. So subtract 2x on each side. You got x plus 6 equals -1. Subtract -6. You got x equals -7. For the letter B, you're going to make this as 4 to the power 2. And this is already 4 to the power 6. Make them equal to each other so that this part equal to this. 2x plus 8 After you distribute, it becomes 2x plus 8 equals 6x. Subtract 2x, you got 8 equals 4x, and when you divide with 4, you're going to get x equals 2. Question number 11, find the inverse of fx equals log 3 of x minus 2. It has this few simple steps. You set the fx equals y and change x and y. So when you switch x and y, it becomes x equals log 3 y minus 2, and then you're going to solve for y. So you're going to change this into exponential form. 3 to the power x equals y minus 2 plus 2 on both sides. You got here is 3 to the power x plus 2 equals y. You can change that y as gx, and that's going to be inverse of the given logarithmic function. Similarly, for number 12, you're going to actually solve for number 12, not find the inverse. 2 to the power 5 is 3x plus 2. 2 to the power 5 is 32. Minus 2 on both sides, you got 30 equals 3x, which means x equals 10. After that, you're going to check the solution. X equals 10. So log 2 30 plus 2 equals 5. Log of 2 32 equals 5, which means 2 to the power 5 is 32. So which is true. This is true. So question number 13, you're going to apply the product property here. So it's going to be x times x minus 14 equals 5. 2 to the power 5 is x squared minus 14. X 32 equals x squared minus 14x. You bring the 32 on to the other side by subtracting 32 on both sides. X squared minus 14x minus 32 equals 0. You can apply the cross method here to solve for the factors, so which means that negative 32 over negative 14. Two numbers you're looking for is negative 16 and 2. So x minus 16, x plus 2 equals 0. X equals 16 and x equals negative 2. You're going to check for the solution. You're going to use is check x equals 16. Plug it into the given equation. You got here is log of 2, 16 plus log of 2, 2. 16 times 2 is 32, and change it into exponential, which is true. If you use the checking for x equals negative 2, right away when I put that as negative 2, I can tell that it's not gonna work because it's giving me a negative of log and is in undefined equation.